Everyone, and welcome to my presentation. My name is İlayda, and today I'm going to talk about a technology that powers almost every modern web application, mobile app, and digital service we use today, cloud-based database systems. In our course, we have learned a lot about how data is structured and managed. Today, we will take that a step further and look at how databases function when they leave our local computers and move into the uh, cloud system. In this presentation, I will explore what these systems are, their major advantages, the critical challenges they face, and how organizations decide between traditional and cloud solution. Let's get started. Before we talk about the pros and cons, let's define what a cloud database actually is. In a traditional on-premise setup, a company buys physical servers, places them in a dedicated room, installs database software, and hires an IT team to maintain the hardware. A cloud-based database shifts this entire model. Instead of buying physical hardware, organizations rent virtualized database storage and computing power from massive cloud providers. The data lives on remote servers managed by third parties, and users or applications interact with it securely over the internet. Uh, Essentially, it turns database infrastructure from a physical asset into a flexible digital utility. When organizations move to the cloud, they generally choose between two main deployment models. The first is infrastructure as a service, or IaaS. In this model, you rent a blank virtual machine from the cloud provider. You are still responsible for installing the database software, configuring it, and managing updates. It gives you maximum control, but requires high technical effort. The second one is, and much more popular model today, is database as a service, known as DBaaS. Here you don't worry about the underlying operation system or software installation. The cloud is a fully functional database out of the box. They handle the patches, the automatic backups, and the routine maintenance, allowing developers to focus purely on their data and application logic. Just like traditional databases, cloud databases come in different types depending on how data is structured. First, we have relational or SQL databases in the cloud. These use structured tables with fixed rows and columns, very similar to what we see in tools like MS Access or MySQL. Examples include Amazon RDS and Google Cloud SQL. Second, we have non-relational or NoSQL databases. These are designed for unstructured or highly flexible data, often storing information as JSON documents or key value pairs. Platforms like Google's Firebase or MongoDB Atlas are incredibly popular in this space because they allow rapid development without worrying about rigid table schemas. Now let's dive into the core of our topic, the advantages. The single biggest reason companies migrate to the cloud is elastic scalability. Imagine you run an e-commerce website, and during Black Friday, your traffic multiplies by 100 times. If you have a traditional local server, your database will likely crash because it cannot handle the sudden load. To prevent this, you would have to buy expensive new servers that sit idle for the rest of the year. In a cloud environment, scaling is elastic. You can scale vertically by instantly adding more RAM and CPU with a single click, or scale horizontally by distributing the database load across multiple global servers. When the traffic spike is over, you can automatically scale down. This level of flexibility is impossible with physical on-premise hardware. Following scalability, the next major benefit is cost efficiency. Traditional databases require massive upfront capital investment to buy hardware, secure a server room, and pay pay for constant electricity and cooling, etc. Cloud databases operate on an operational expense model, usually called pay-as-you-go. You only pay for the exact amount of storage and processing power you consume per hour or gigabyte. This lowers the barrier to entry for startups and small projects. And another massive benefit is global accessibility and high availability. Because the cloud infrastructure is spread across worldwide data centers, developers and users can access the database from anywhere with incredible speed. Furthermore, cloud providers automatically replicate your data across different geographical zones. If a power outage or natural disaster hits one data center, another one another one takes over instantly, ensuring zero downtime. While the advantages are powerful, cloud databases are not perfect, obviously. We must analyze the challenges. The most prominent concern is security and privacy. When you put your data in the cloud, you are handing your sensitive information over to a third party. Cloud providers use a shared responsibility model. This means they secure the physical buildings and networks, but configuring the access rules, passwords, and user permissions is entirely up to you. A single misconfigured setting can expose an entire database to the public internet. Additionally, there are strict legal compliance challenges. Laws like Europe's GDPR or Turkey's KVKK dictate exactly where citizens' personal data can be physically stored. If a cloud provider hosts your database in a country that violates these local regulations, your organization could face massive legal penalties. And another serious business challenge is called vendor lock-in. Migrating a database with terabytes of data is a complex and risky process. Once you build your entire application using specific proprietary features of one provider, let's say Amazon Web Service, it becomes extremely difficult and expensive to move your data over to, I don't know, Google Cloud or Microsoft Azure if they offer a better price later. You become heavily dependent on their ecosystem and pricing changes. And finally, we cannot ignore internet dependency and network latency. Traditional databases on a local network can be accessed instantly even if the external internet goes down. But cloud databases require a stable, high-speed internet connection. If your local office loses connectivity, your operations grind to a halt. Furthermore, if your application server is far away from the cloud data center, data travel time, known as latency, can slow down your system's performance. To summarize everything we've discussed, let's look at this comparison table. As we can see, traditional on-premise systems give an organization total physical control and zero internet dependency, but they demand high upfront costs and offer very slow, painful scale. And cloud-based databases remove the burden of hardware maintenance, offer incredible elastic scaling, and save money through flexible pricing. But they introduce vendor lock-in risks and require strict attention to cloud security settings. For most modern applications, the agility of the cloud easily outweighs the challenges, provided the system is configured correctly. Thank you for listening me. If you have any questions, you can ask me through the comments. I will be very happy to answer it. And here are my references. Bye.